Hello everyone, I would like to welcome everyone to our product showcase presentation, Best Practice for Air and Windtight Structures. I would like to thank Partel for their support of New York Passive House throughout the years as a sponsor. It is very important to us to have such a strong partner. It is my pleasure to introduce Caleb Crawford, who is a New York Passive House board member and will introduce today's presenter.
The company's objective to provide quality, advanced technical solutions and specific materials for the building sector came from a passion for passive construction and architecture. So as Andreas mentioned, Partel is a sponsor of New York Passive House. I think they've been sponsoring us for at least 4 years. And we'd really like to welcome you. So Hugh, take it.
Thanks very much, Caleb. Thanks everyone for taking the time to attend. The idea or the aim with this presentation, I suppose, is to provide an overview on the best practices for air and wind-tight sealing. But I want to give you some building physics information, so also kind of maybe some of the why that we do these things. And that can apply from the membrane or the sheet applied through adhesives, testing and case studies. If it's okay, I'm going to deactivate the camera now and switch to mic only, just to, I suppose, help the presentation be as smooth as possible. I am an active CEO of the company. I suppose, I mean, I am our technical manager. I'm thoroughly involved or heavily involved in the product development, the product design, the R&D side of things. That's kind of my area, together with the building physics side of things. Just a little about Partel. So kind of as Caleb mentioned, we're founded by architects, engineers, I suppose with a long experience of various types of construction. From there, we went down the route of passive house designers and became aware of some of the shortfalls in the market space, but maybe also some of the lack of specific products for relevant markets. And we thought we could do things a little bit better, and pretty happy and found out that we can do that. So we tend to make more bespoke products. We try to be a little bit more reactive to individual markets, and New York Passive House is certainly different from the UK or the Irish market. So we have been able to adjust some products to suit this market, and being a younger company, that kind of thing is a little bit easier for us. We have developed strong manufacturing partnerships. Distribution is in Connecticut, and we do a lot of, I suppose, technical support work. So if there's various questions, it could be from a building physics point of view or application knowledge, we're quite comfortable in that space. It used to be the case that most of our products were focused on residential markets, and we have found that that started to change and become closer to parity for residential and commercial. And kind of following on from that, most of our products apply to internal and external. So it's always a full system, be it a full internal and external system. And we're very sure that our products work well with each other. And the ultimate aim is to improve building, I suppose, security, stability over time. And if we're using full systems, we can have a better chance of that. Our kind of range is separated into 4 main categories. That's the air and wind-tight membranes, or the WRBs, the sealing tapes. We do quite a few different types of adhesives, sealants and primers, and quite an interesting area is thermal bridging. So it's more of a solution orientated space to thermal bridging, and yeah, maybe not the highest volume for us, but some really good products. So why do we want to build airtight? Kind of these questions probably maybe easily answerable to some, but we'll go into them in a little bit more detail. So to lower energy costs is one everyone gets and everyone kind of understands, and let's say it makes sense. But maybe some of the more tangible benefits are that we can improve comfort levels. So if it's I suppose a good description is 2 houses side by side, one built to a passive house level, one built to a pretty low quality. The likelihood is that the overall temperature, or the maximum temperature in the passive house will be higher, because we feel those drafts, we feel those cold parts in those buildings, and we tend to actually seek to have the higher temperature internally. So yeah, if we can build to that lower level, a more even lower temperature, we'll feel more comfortable. There's kind of nothing more prevalent or for a discussion topic now than indoor air quality, but obviously passive house and airtightness, they're very much aligned with air quality. So it connects with our mechanical ventilation systems, but they're a big part in managing our indoor air quality. They can control and help with mold, prevent pollutants from filtering into the property. That could be from breakdown of insulation materials through the exterior walls, things like that. The last one is structural integrity. I'm an engineer myself, and I feel quite strongly about this one. Kind of what we mean when we talk about this is our airtight layers, they really mean more than just airtightness. So they're all quite technical. They all help us control vapor in the, I suppose, in the property. So we generate a significant amount of moisture in our buildings, up to 12 liters per person or per typical household per day. So we need to be able to manage that, and we need to be able to manage it separately to our I suppose to our ventilation system. So you will find, and I'll try to give a little bit more information about how the breathability of these membranes kind of works. But really, a key aim of the products is to maintain the structural integrity of the building. So if that's a timber roof, we're setting it up so that it has a possibility to always dry, and we're preventing it from, from air leaks, but also from vapor movement through the building. Interstitial condensation is one of the kind of big ways that we can have a building failure. The image on the right may be exaggerated a little, but if we kind of visualize it as a standard timber frame building without a vapor control layer on the inside and with an OSB just inside the WRB, what will happen there on a cold day outside is that nice warm humid air will travel through the construction. It'll reach a dew point or the OSB and start to condensate in the structure. So, quickly by installing a vapor control layer or an airtightness membrane in that construction, we prevent that warm humid air from cooling and condensating. So it's really a critical part of the infrastructure of a building. The other kind of thing to be aware of is that the warmer the air is, the more vapor it'll hold. So it can be the case that we've got low, maybe a 50 to 60% humidity inside the building, and people might say that's not a problem. It's when it cools, it loses the ability to hold that volume of vapor, and that's what creates the problems. The word breathability is mentioned a lot in construction, and I think probably not always understood. When we talk about breathability in buildings, it always refers to water vapor, not to air. So that, at least that's what it should be. I think it's probably not always understood as that. So a building can be airtight and still breathable. A building fabric can be breathable, not breathable. Either one of those ones can work, but it should also be known that a breathable building fabric isn't a compensation for fresh air. We still need our mechanical ventilation system. The idea with the image in the bottom there is to try kind of visualize, what is classed as vapor tight, vapor open. We're trying to kind of give an illustration. In Europe, we use the term SD value, and it's quite a nice way to visualize it. It's the equivalent airspace measured in meters. So if we've got an SD value of 0.1, that's 4 inches, it's essentially how long it takes for water vapor to pass through 4 inches of air. If we move to a more closed product, something like 1500 meters, we can kind of visualize how long does it take water vapor to pass through 1500 meters of air. So kind of all of our products relate back to that, and you could probably also imagine that we want to set up our construction so it's layered correctly, so that it has the ability to dry. Normally, that's, in your case, moving from low perm to high perm and becoming more vapor open as it goes to the outside. We rely and I suppose invest quite a bit of time in WUFI analysis. WUFI is a dynamic modeling tool that can give us pretty accurate outputs based on I suppose it means the better the quality we put in, the better the idea we can get of how the building will actually perform over a period of time. If we use a more simple kind of way of checking condensation, it can lead to pretty big risks. So really, WUFI is something that we need to use for all flat roofs, for all walls that don't have a drainage plane. So kind of in New York, that's pretty much everywhere. And it means that we should be using WUFI to analyze the walls and the roofs. I want to give you an idea of kind of what a typical WUFI analysis starts out as and the type of information we can get from it. So this is a timber frame construction. It's got a rain screen, with the brick outside it. It's got 2 layers of OSB with a wood fiber insulation in the middle. On the right-hand side is actually how we will build our WUFI model. So we've got the brick, which is the red, the light yellow is the wood fiber, and we've actually been able to simulate things like the actual air leakage of the building. So we can tell it it's got an air changes of 0.6 if it's passive house, or in this case we had to simulate for 3. We can also simulate accurately the amount of air changes in the ventilation plane. So this is a typical output. We can check things like the relative humidity in the various points in the construction, but in this case, we're looking at the products that can fail. So on the outside, it's the exterior OSB layer, and it shows us that we've got a summer drying kind of graph, or summer winter drying. It tops out at about 16.5% moisture content. This is the exterior layer of OSB. So people will often kind of think, look, above 16, so long as it's under 20%, it's okay. The reality is, it may be okay, just about okay, but it's really on the limit. So when we see something like that in WUFI, we are really pushed to, we would class it a little bit over the borderline, and we'll be making recommendations on the construction. Can you adjust it? Is it possible to make the exterior layer a little bit more breathable, a little bit more vapor open, and in that way we can reduce that moisture content. So kind of following on in that construction, this is what the wood fiber insulation will look like. It's about, an average of about 10.5% moisture content, so no issues there. The interior layer of OSB, much lower risk, and it's about kind of average of 8% moisture content. And this is an example of what would happen if we change the exterior board to a more vapor open. It's a pretty dramatic difference. We were at about 16.5% moisture content. Quick change to more appropriate product, and we come down to about 11.58 average kind of percentage on that. So it's a dramatic difference, and what it actually builds is a safety barrier for let's say workmanship issues. If something doesn't happen on site exactly as we planned it, we have a little bit of a buffer. So it's pretty much how close do you want to stand to the subway line? Do you want to stand right up on it, or would you be comfortable standing back a little? And this kind of change to the Medite board or the vapor open board really brings it into a safe level of construction. If we have higher moisture risks, there are kind of different types of products out there. So you'll kind of hear a lot of talk in the industry about, I suppose it has 3 different terms. It's a variable, it's a smart, or it's an intelligent airtight membrane. For us, they're useful. They're not the only product that you need. They can certainly be an advantage and necessary in some constructions, but I'll try to give you an idea of kind of how and where we use that. But overall, as a kind of a general level, what it has the ability to do is increase the drying potential of your building. So it can allow summer drying and increase protection in winter. We have this sheet applied product, VARA Plus is its name. So this is our smart product. It has the widest ST value on the market. When you present that in perms, it's actually not the widest perm rating, but ST value is based on that meter kind of, let's say the meters of air. So for us, it's a good way of assessing or kind of valuing the product. It's a reinforced product, so quite tough, can be used with cellulose insulation. And we do couple it with a fluid applied product. So this is VARA Fluid. It's a spray applied and brush applied product. It's a commercial and residential product. You can get a little kind of video on the product here to get an idea of how it works. It's a product that we've had a good bit of use for in New York, and we'll show you a case study or two with that type of product shortly. But it's for our industry, it's the biggest change there's been in about 10 or 15 years to have a fluid applied vapor control layer. You can see it here being applied as a first coat. On the bottom, there was a brush applied, and this is a, if you like, a priming coat that's going on it right now. The coverage will increase with the second spray over. The product is tailored, with feedback from the New York market actually. So what we've been able to do with that product is make it a little bit quicker to dry and possible to apply it in thicker layers. So you've kind of two options. If the weather permits, you can apply 2 coats in one day, or it could be possible to apply one heavier coat. We do have a full kind of system, or a full smart system, that brings us also into airtight tapes, which also carry the variable or smart function. There's 2 different tapes in our product line. One is VARA Seal, that's an overlap tape, but also a split back tape for windows. And we carry it as a VARA Seal X, which is a pre-application tape for windows, and I'll show you a couple of images and videos of that as an install. Kind of a little bit further on the variable products, I wanted to show you a further WUFI output from a flat roof construction. So maybe a little bit more typical kind of for you. It's got a plywood deck. We've used some insulation over the plywood. The reason for that is to, I suppose, to manage the moisture content and help to protect the deck. With cellulose fiber insulation underneath, and with VARA Plus membrane compared with a fixed perm. So it's not this kind of, utterly dramatic difference in fixed perm versus smart perm, but the differences are significant. It's dropping our moisture content down to a very kind of acceptable level, and it's doing it quicker. So over a period of kind of 5 years, the variable product is giving us a greater level of safety, and it's actually increasing, if you like, the gap between that and the fixed perm. Maybe going on to kind of how we achieve a good quality airtight structure. So we like to look at it as 3 steps. So design is the first stage, and that's, kind of the architect's job is to try find a way to make it possible to have a simple structure. So hopefully it's not too complicated. And there is kind of always an easier way to approach it. After that, we have the QA on site. That's really critical, and it kind of means that we need to get a buy-in from everyone, from all the various trades, to be able to I suppose, to support the airtight installer and not to disrupt or damage his work. We've then got to test and test again, and it should always be a 2-part process. We really want to do an airtight test kind of at the stage where the membrane or the sheet applied product is in the image on the right. So that's the time to do a detailed test. That's when you find your leaks, and that's kind of when you do the hard work. So the longer you run a blower door test kind of at that time, the better your final results will be. So going on to the details, we're probably all, have seen this red line drawing, and, obviously it's easy to do in this instance, but it's an important part of the process. So what we really want to do is decide what is your airtight layer in each location, and what are the connections that we have to deal with. So coming up with a kind of a plan that allows us to, I suppose, achieve all of those details. We will provide a lot of kind of standardized details where we've done a lot of the, I suppose, the thinking and analysis on that, and it'll allow you to get a good quality spec. So kind of here you see 2 options on the interior sheet applied. That could be isoperm, a fixed perm, or also VARA Plus. You've got the appropriate connection tapes, and the same on the outside. This is I suppose, a section of the flat roof that we looked at in WUFI a minute ago. So we kind of really need to be able to take that purple line, the VARA Plus line, down to the underside of our ceiling joists or rafters. It's kind of necessary to get a good connection. So that type of a hybrid roof, maybe it's not traditional, but it is quite a safe way to do it, and it's a necessary way to look at a certified passive house flat roof. Moving on to the QA on site, some nice quality images that people might enjoy. The one on the left started out as something really good, actually. You can actually see our membrane behind it. So it was a prefabricated, an off-site timber frame delivered to site, perfect airtightness, good quality reinforced membrane. And that was the last consideration that anyone gave to airtightness on that site. So they unbelievably achieved airtightness of 12 on their first house. And you can kind of see in the second image how they managed to bring it down to about 9. Lots and lots of spray foam. The houses were finished, but yeah, the people who lose out is it was actually a multi-unit housing estate. So it's the end users, the buyers, who end up with these, really leaky yet expensive homes. This is the contrast. If it looks this good and it looks that neat, the end results will reflect, and you've got a really durable, long-term kind of airtight system. The airtight test, I guess everyone is kind of, I suppose, quite up to speed with that, but we love it. It's something that doesn't lie, for a builder or a contractor. It's his only kind of test on the overall build. So there's no kind of marks on everything else he does. This is transparent. If he can achieve 0.6, it really says or tells you what kind of quality you can do. So it's a real quality mark if you're looking to contract someone to build for you. Were they able to achieve 0.6, or if not, what are their proposals to do it? We like to focus as much on the exterior products as we do on the interior. WRBs, breather membranes, have a huge variance on the market as to how they're constructed, and that in turn has a huge impact on the longevity of roofs. But kind of focusing on the energy performance first, we would always like to tape and to seal our WRBs. The reason for that is we want to prevent, we really want to prevent the wind from blowing through the insulation. So the analogy of the person kind of outside on a windy day with a woolly jumper on, it's not much use. You put a wind sheeter or something to protect you from the wind, and that's kind of the difference. So it's the two parts together. Without that, in an exposed roof or an exposed site, your U or R value can be as much as 1/3 worse than planned. So that's really significant. That could be, if we take two houses side by side, one has got 12 inches of insulation. It's got good wind tightness. The house next door without good wind tightness could need an extra 6 inches of insulation on top of that to get the same kind of functioning value. So it's really significant, but obviously there's a difference with warm roof and cold roofs, but if the insulation is tight in the slope, we should always be making it wind tight. On the market, in terms of breathable or vapor open technology, there are currently kind of two types. Microporous is dominant or the most popular. It's about 20 years since this technology was developed. We've aimed to kind of create a visual representation of how vapor moves through a microporous product. It's a physical transport. It's created by producing a product that has some calcium carbonate added in it. The product is stretched and it forms tiny little holes in the product. It's actually those holes that make the membrane breathable. So it's quite a cheap system. It can look the same as the better quality monolithic one, which can be an issue, but ultimately they tend not to have the same UV stability, and they're generally bonded just with heat, so not actually, with full adhesive. The monolithic on the other side, which is the products line that we work with, they've got a solid closed layer through the middle. It allows the passage of vapor through it in a molecular way. So there are no small holes. There are no small holes that can get blocked. Quite good UV stability, and we tend to use good quality non-wovens that can help us with that. So really we're looking, when we take our products compared to the lower ones, lower cost ones, you can be looking at kind of 10, 15 times difference of a lifespan. So really, really significant when you take roofing costs or facade costs into account. just kind of to show you, I suppose, that's what a typical 3-layer product looks like. It'll always look the same as the cheaper products because it's got a similar type of non-woven on top and bottom, but kind of in the middle, that's where the important work is done. There is a next generation type of product available for us. That's Exoperm Mono Duro. It's a 2-layer product. You'll kind of see the product has a type of a sheen on the outside. It's a TPU coating. It'll look and feel like a little bit like a fake kind of leather, but it's a really, really high performance, long life product. These products we expect to last kind of 50 to 70 years. We're offering a 15-year warranty with them, and they're also fire rated and highly UV stable. So these products can actually be used in open joint facades for up to 10 years. I want to talk a little bit about adhesives. It kind of goes without saying that as good as our membranes might be, it's, you know, our tapes are kind of what we're known for, and it's really, really important that the tape is pretty much better than what it's being adhered to. So we spend more money on our tapes and our adhesives than most people. We never expect to be the cheapest, but we are focused on quality and longevity. The adhesive has a pure acrylic base. We can then modify that to give us the characteristics we want. It means that if you compare our tapes to somebody else's, and it's the same for any kind of really good quality tape provider, a low kind of thumb tack, if you like, if you put your thumb on the tape, we won't be the best on that, and nor do we want to be. We're looking at a 24-hour strength, and after that, that's a really good indication of the real long-term strength. So we kind of sacrifice some of the tack and end up in this kind of, if you look at the graph on the bottom, in this kind of middle ground where we've got really good quality peel, tack, and cohesion. So we have a balanced adhesive that is long life. The adhesives we use themselves, they've got excellent temperature resistance, you know, overall systems that can withstand damp conditions and generally can be used internally and externally. The tapes themselves should always be about 60 millimeters or 2¼ inch wide. If we're bonding 2 products, we really want 1¼ on each product. We also need enough weight of adhesive to be able to close and fill gaps. And I suppose separately to that, the different carriers on the products. So what is the tape made from? We use that to give it different qualities. So in the VARA product, we're able to use a smart function. We can apply our standard coating with that, but the tape you see being tested there in those images is Kineso. It's a paper-based, more an ecological tape, but it's very much dimensionally stable. So there's always different kind of characteristics within the tape that people might like to use. We test quite a bit both externally and internally. So if people have requests on a particular adhesion or they want to test, you know, let's say a cement board or a wood fiber board, we can carry out those tests. Generally, the quality of the adhesive is also another part, but we need to be sure what the surface it's been adhered to is like. So number one, the surface needs to be clean and dry. We should consider using a primer on any porous surfaces, and it also makes sense to do a test case if it's something different or new. The adhesives themselves are also pressure activated. So when we apply them, we will always apply some pressure afterwards to help activate the adhesive. So it's kind of like the last thing you do in an install before you go at the end of the day. You'll revisit all of your tape connections and make sure that you've got a good pressure applied or a good bond. If you want to check how strong the adhesive is, you really need to wait 24 hours. That image on the right, kind of just for fun, is that same project where they achieved the really low quality results, and instead of using a tape, they used varying amounts of spray foam to connect a good quality membrane to the cheapest piece of plastic they could find. So yeah, not too much of a surprise that they ended up where they did. This is an example of, I suppose, kind of how you might test some of the tapes internally. It's a peel test, so I suppose fairly technical in that we're measuring at a particular speed, at a particular strength, and we're trying to gauge exactly kind of how the tape works. So this is Kinexo, it's our most popular tape. It can take incredible loads after it had full adhesion. again, the carrier is kind of different. If we had used a different carrier, that's quite a flexible carrier, so it gives us some stretch. Some of the other carriers can allow us to fail in a different way, depending on what you're looking for. Kind of talking about testing, I suppose our favorite kind of overall test is the Passive House certification test, because it's the only complete system test focused on airtightness. So there's a lot of individual product tests, but for Passive House, it's excellent. We're this particular Isoperm Plus test, it takes into account Connexo, VARA Seal, so all of the tapes, the adhesives. It takes into account in masonry, timber, and also membrane to membrane connections. So quite thorough, independent, and a really good gauge of where it is. So it's pretty much a zero leakage on that system, and something we're quite proud of. You'll find with our tapes that you'll have a good idea what they do based on their name. We're not I suppose we're not, it's originally an English design, I guess. So you'll see Connexo, our exterior membrane line is Exoperm, Connect Exo or ConExo, that is the idea. So you'll have an idea that that's an exterior tape. You can use it internally, whereas Coneso is Connect Isoperm. So it's really just to connect this membrane. It's an internal tape. VARASEAL on the bottom is an all-rounder. You can use it inside, outside. It's got a smart function, so you can actually use it to seal windows and doors internally and externally. Our product range is quite deep. While it is the case that you tend not to need to use too many products for most systems, they're all here. And just to give you an idea of kind of some of them, we do wide kind of butyl-based flashing tapes for under sills, nice good quality grommets, and the pre-compressed tapes, which we're a big fan of, and they can be a good fit for commercial projects. The pre-compressed tape you see in the bottom left actually it's also a variable product. It's got 3 built-in layers of a smart product. So it's airtight, it's windtight, it's weather-tight. So it's kind of one tape that does all of those things. Another reason why these tapes can make a lot of sense in the in the bigger built-up areas is that they help us achieve real kind of sound insulation on the final window install. So if you've got a good quality triple glazed certified Passive House window, it's logical that we should want to complete that install with a good quality tape like that. So caulk and backer rods will not give you the same performance in terms of decibel level protection. So just to take us through a few kind of, let's say, kind of local Passive House projects. This is 280 Carroll Street. So while these Brooklyn brownstones look great when they're finished, I wanted to give an idea of what it was Kevin Brennan of Brennan installation carried out the install. So just to give you an idea, kind of the level of work and expertise and effort that's required to bring it to the Passive House level. So he's starting out using kind of bricks, very much variable kind of quality, significant holes between the bricks, and you're also dealing with really old timbers with huge gaps kind of going right into party walls. So a real challenge in kind of how you make those airtight. Basement is pretty much the same kind of issue. You've got these really challenging connection problems right the way through. The 2 photos on the right are an ongoing process with the fluid applied product. So you can see the contrast in the central one where they're actually having to gap fill, those large gaps in the brick. And then over kind of spray or brush on the fluid applied product. So it's not, unfortunately, not as easy as kind of coming in and just spraying right over the whole thing. There still is a fair amount of attention to detail and consideration needed for kind of all those small things. So the end result is good. You kind of get there, but there is a certain amount of gap filling or preparation needed to be done for those old brick walls. In the same image, you can see kind of what he's doing with the VARA Plus membrane. It's been draped through from one floor to another, and it's allowing us a connection between floors. This is an example of the VARASEAL X tape. It's being pre-attached on the windows. So the windows are prepped fully before they're installed into the opening. This is just a short video of Kevin working at what I assume to be his natural speed. but he's got one airtight membrane already, or airtight tape already installed. He's doing the second on the other side. So that window is using a smart tape inside and outside, all pre-attached to the window. So when it's offered up, it's remove liners and apply the adhesion. Again, not that it's simple, but good quality detailing can give you really good results. This is 86th Street in Manhattan. We were contracted to supply the fluid applied products to the party walls. So again, it's the spray applied product on each floor. These types of buildings have their challenges, but this type of product just makes a lot of sense in these ones. Maybe the only kind of issue that they had with this is that the ACA blocks needed to have a little more attention to detail. So the actual installers needed to point the joints and leave the block a little smoother. If you were spraying, kind of like in the brick ones earlier on, if you're spraying onto an uneven surface, you're less sure that you've got full coverage if you're having to spray on top and on bottom of kind of different areas. So if it's a smooth surface, it's very quick and easy to apply a good quality cover of adhesion or of the spray applied product. The last project, or last one of the projects I wanted to show you in the US, it's a Habitat for Humanity. I like this project because it's a volunteer install. So it's a really simple type of install, a really simple type of design, but they've done a good few of these projects and can always achieve 0.6. And I've seen them post-install, after the volunteers have applied the tapes and membranes. Because the system is pretty simple, it means the results can also be quite achievable. This is an example of the Exoperm Duro, let's say the highest quality kind of WRB product or next generation. It's a I suppose a UV stable, long-term fire rated product, really, really high quality. And this is the kind of 50 to 70 year product. The next image kind of shows a timber frame company that we've worked with a lot. They use a different type of exterior product. It's still monolithic. It's the Exoperm Mono. On the interior, they've always used Isoperm and what is actually a passive, a solid board with an airtight layer on it, and they'll use our tapes to connect. But again, it kind of looks like any good quality airtight install will look simple if the finish is good, and that's kind of what that one looks like. It's been a lot of the risk has been designed out of it. To give you a little idea of the thermal bridging solutions that we offer, Almatherm, really, really interesting product. It's completely recycled. It's actually produced from PET plastic bottles. So that's the typical water bottle that you get in the local store. It can be used internally or externally, and it can take enormous loads. So for us, it's a key product for supporting windows and doors. It gives us a really good thermal break, and we really don't need to do a great deal more with it. We do manufacture whole thresholds. It could be from Almatherm or also compact foam, which is another product we work with. And this kind of would show you the same type of application. Compact foam works in the same spaces as Almatherm. It's an EPS-based product, but both of them are really, really interesting. They can be treated like a piece of timber on site. So any of your kind of woodworking tools, saws, skill saws, we can drill it, anything like that. Really, really simple product, and deals with a tricky junction at doors and windows. So just to kind of recap a little, kind of what you can get from us, it's always a system and product warranty. We carry in design indemnity, also insurance backed. We do a huge amount of external product testing, and that's from BBA, CSTB, the Fraunhofer, PHI, and pretty much the same internally. We'll do our own adhesion, breathability, and weathering, strength and aging testing. We're kind of proud of our engineering background, and I've always found that makes us relatable on site, but also to architects and engineers. So we try to understand where you're coming from, and we're happy to back it up with WUFI condensation risk analysis as needed. Caleb, I think I'm not too bad on time, about 45 minutes, I think. So yeah, very happy to take any questions from anyone.
Well, early on there was this question about what is the SD?
Yeah, it's a so an SD is it's a European way of describing perm, basically.
Ah, okay.
Maybe not that interesting, but
Yeah.
depends on the person. But I do like how it's kind of represented. So essentially, it's the equivalent airspace. So if we've got something with an SD value of 1 meter, that's how long it takes water vapor to pass through 1 meter of air. So it's a good kind of visual. Obviously, it works for so a typical breather membrane would have an SD of 4 inches, something like that. So it's how long water vapor takes to get through that little space, whereas your air and vapor control layers would have many, many multiples of that. So it's a nice visual. We're letting less vapor into the construction than we're allowing out of it.
Yeah, I mean, there are some more general ones because I guess maybe people were sending directly to you. I've just seen a number of general ones like, do you have environmental product disclosures for your products?
Yeah, we have some, and we're committed to, and we've started the process for quite a few more. So VARA Plus is ongoing, Exoperm Duro, the same, the thermal bridging product already has it. So yeah, we believe pretty strongly in that. So we're working on international EPDs for those. So I would say kind of before the end of the year, they'll be in place.
I mean, I think you kind of addressed this, but are your tapes and other adhesives all low or no VOC?
Correct. Yeah, exactly. Yeah,
okay.
We're completely solvent free. It's a solid acrylic adhesive.
So then there was a question about PPE, personal protective equipment required for application of the spray on. I mean, it is an aerosol, so I would assume that some is required.
Yeah, it's not harmful, but it's certainly smart to wear PPE for it because of overspray and that kind of thing. So yeah, definitely.
And then life expectancies. I suppose that varies on product, but
yeah, I mean that's a good question. One we like. We're sure from testing that our tapes will outlast what they're attached to, whatever they come across. So yeah, we'd be looking at lifetime is the term we would use. So yeah, it'll for sure outlast whatever it's attached to. It does. It's the adhesive itself doesn't age.
There was a question on wind tightness and whether that's something that you actually measure, or is it just primarily the 50 Pascal kind of air change that you're going
Yeah,
after?
it's a good question. I suppose there's two things on that. We need enough strength on our tapes to be able to withstand more than the 50 pascals. So we'd actually design them to be much stronger than that. But I suppose separately to that, it's more that you can test an actual functioning U value or R value in place these days. We'd work with some technical kit like wireless R value measurements. So you can actually see what a U value or R value is like in practice. And that will vary relative to wind tightness. So it's kind of logical if you allow significant wind to pass through the insulation layer, it'll have a cooling effect.
And then I have a question because are you familiar with Building Green?
I'm familiar, I think, but I honestly, you see so much, I struggle to.
Peter Yost. I mean, they're a nonprofit. They're sort of like a Consumer Reports for sustainability in buildings, and they did a thing called the Wing Nut Testing Facility.
I have seen it.
WTF for short. But basically, what they try to do there is they've tested a lot of products in what they would consider to be actual job site conditions, like dirt, cold, wet weather, and see how things apply. But I think what your presentation kind of showed is that attention to detail, cleaning the thing before you actually adhere it is a really essential thing. You can't just be an American all the time.
Yeah, it's got a. I won't comment on the last part there, but I think, yeah, like for sure, I think it's a good kind of way of phrasing it there, that the costs of the airtight material are actually quite low. You know, people will say, yeah, it's expensive for a roll of tape, but really it's the labor that takes time. And when it comes to labor, once is really enough to do it. It's a much more expensive thing to have to revisit it. So yeah, a little extra time to get the surface preparation right makes a dramatic difference.
Yeah, actually, when that project that you showed with the wonderful air conditioning piping installation, that was
Yeah,
Ireland.
that was Ireland. Yeah, yeah. I'm normally
Must have been
more
hiring
proud.
American contractors.
No, they're everywhere, those contractors, I'm sure. Yeah. I was surprised. I hadn't seen anything like that in a good while, but yeah, look, it'll always happen, I guess. Yeah, the lowest price, isn't it?
I have a question from a countryman of yours, David Hughes,
Ah, yeah.
and he was asking about in retrofits, it's about full fill insulation between rafters. Do you have to remove the sarking layer, which was a new term for me?
The one where he's asking how you deal with the ends of joists going into walls. That one is kind of been I suppose the fluid applied has been a really good product for that. It used to take a really huge amount of time. So we used to have to prep and tape around each end joist, whereas now you can use a paint and then spray applied, fluid applied product. So it's a huge difference in time. You still have to give it kind of lots of detail and attention, but that's a big difference. In the possible moisture in the timber is that in that location, David? I guess that if that's in the same location, the product that we apply, the VARA Fluid product, is actually vapor open. It carries the same smart function, so it will allow the timber to dry post application.
One question I had actually is, so how do you distribute your products? Is it online order only, or how does it work?
Yeah, it's online, but it you know, we for sure online is there, but you know, we do distribute in pretty much most of it would tend to be calls and contacts, Andreas, so we'll end up dealing directly with the customer, but it is all direct at the moment.
Hello, Hugh. It was good to. It was funny that we would talk via New York when we're in the same country, but such is the world of the internet. No, good presentation. No, my question's really. Some people may be familiar with the book by Marion Bailey, and she did quite a lot of studies and actual realized projects. They're all captured in the book. And one of the things she seemed to do, which seemed quite extreme, was to cut back the ends of the timbers and put in a sort of bridging piece so that the section in the insulation would not be susceptible to moisture buildup. And maybe, you know, it's a very extreme way of dealing with that problem. I just wondered, had any, let's say, less invasive solutions been developed?
Yeah, I mean, I guess in those roofs, David, we are assessing the moisture content of the timber, or we can in those roofs, you know, using WUFI 2D or 3D. So you can get a pretty good idea of how it will perform in that way if necessary. So yeah, I would tend to rely on that and err on the side of caution and try to make sure that the timber, you know, is in a pretty healthy place, you know, down at that 13–14% if possible.
Yeah, well, in any event, if anybody is interested in that particular book, I'll share a link. You can get me at david.hughes@irishrail.ie, and I'll send you the link.
Okay.
Could you put that link into, or your email if you like, into the chat box?
Yeah, I'll give you my email, and then anybody who's interested can email me.
Susan had a question about the testing facility, the wing nut, which is you know, it's a comic term, testing facility. They were obviously having fun with it, and it was a purely unscientific. They got a whole bunch of tapes and a whole bunch of substrates, and they put a bunch, and they put like weight on it and waited to see how it failed.
Yeah, I saw it. It's a long time ago. I remember kind of seeing it. It's a good test for, I suppose, to determine the shear strength of the adhesive.
And
it's
and
a clever thing to do, I think.
Yeah, and then just, you know, how the adhesive would hold up on like being applied on a job site. And the odd one was that it was a zip system tape that actually won out.
Really?
Yes.
Interesting.
And I've actually had people who like say that for sealing, particularly on floors where there's a lot of traffic before construction has been completed, that the zip system seems to hold up particularly well.
I think a lot of the adhesives, there maybe isn't enough focus on the carrier. So, you know, for example, the wing nut testing, if you take a product like Conexo, which is quite a thin film, it's very flexible, it wouldn't do that well in the wing nut testing, whereas Kineso, as a dimensionally stable product, would do very well. And then kind of further on, a thicker carrier probably do very well in the location you just mentioned, where it can take that extra wear. So the carrier is kind of often ignored, but it's a huge part about how the tape functions. So we tend to have 3 different primary types. It's the paper based, the fabric based, and then the light kind of flexible PE based product.
As Hugh knows, I deal with a lot of kind of historic buildings. Sometimes they have timber floors. Sometimes the original timber floor has been replaced with a concrete floor. So when it comes to insulating, the question is whether you should remove the concrete floor or maybe put a new floating floor, basically insulation on top of the existing concrete, and then the floor finish of choice on top of that. And if you agree that that is the better way, where should you put an airtight layer? Should it be beneath the insulation? Should it be between the floor finish and the insulation? Or would you not agree with that?
I like to have the airtight layer below the final floor finishes. I think it's, I actually had personal experience where I had to do a little bit of air sealing to a concrete floor, and there was some floor finishes to be applied in my absence. And when I returned, all of the airtight tape had been punctured, ripped during the floor install. So if it's protected at a lower level, you know, it's a permanent lifetime job. So I would always choose that.
Okay, I guess we get to the 1 hour mark. I would like to thank you for your presentation, and Caleb for participating. Yeah, we will send out the recording and also your contact info to everyone, and you guys can continue the discussion offline, I guess.
Great. Thank you, Andres.